So in this video, I'm going to go over the basic types of reactions that you will come across. I'm going to start off with talking about synthesis reactions, then decomposition, and then combustion. And then in the next video, I'll go over single replacement and double replacement. So really quickly, one of the key things for you to remember when we're working with reactions is that some elements cannot exist by themselves, and there's 7 of them, and they are called diatomic elements. Now these elements include nitrogen. So instead of just being N, it's going to be N2, it's Cl2, O2, Br2, I2, okay, H2, and the very last one is F2. So those are 7 that you need to remember. They make a 7 on the periodic table if you look at them, all of them except for hydrogen, okay? So for synthesis reactions, there are really 3 major types that you will see. You will see the formation of a binary compound, so 2 elements combining together to make a compound. So for example, if you have Na reacting with Cl, and remember it's going to be Cl2 because chlorine is diatomic, it's going to produce NaCl. I crossed my charges to get that. So that is forming a binary compound. Okay? If you have a metal oxide in water, now a metal oxide is a compound that has a metal and oxygen. So for example, if I have calcium oxide, for example, and I react it with water, what's going to form is a base. Now a base is an ionic compound that has OH at the end for the most part. There are some exceptions which we'll look at when we get to the acid-base unit, but they are compounds with a metal followed by OH. Now in order to write the formula for a base, all you're going to do is you're going to cross your charges. So calcium has a 2+ charge, hydroxide has a -1 charge, and so this is going to be the formula for my base that is formed. The last example is a non-metal oxide in water. So for example, if I give you SO2 and I react it with water, what's going to form is an acid. Now an acid starts with hydrogen like we talked about when we were naming, and then it's going to be followed by your non-metal. So it's going to be hydrogen, then your non-metal, and then oxygen. Okay? There are some exceptions for acids. For example, acetic acid, which does not start with H, but for these problems, we are going to be dealing with acids that start with H. Now, the cool thing for creating an acid is you actually balance as you go. So here I've got hydrogen. I'm not going to be crossing charges. I say, okay, I've got hydrogen, I've got 2 hydrogens. I've got my non-metal, which is sulfur. I've got 1 of those. And then I've got 3 oxygens total. So this is sulfurous acid, which is formed when sulfur dioxide and water react. So that's a synthesis reaction. So if you look at this example here, it tells you that hydrogen is burned in air. So hydrogen, which is diatomic, burns in air. Well, we assume that air is oxygen. So what's going to form if you have hydrogen and oxygen is H2. Oh, oxygen has a -2 charge, hydrogen +1. There's my compound. That is the formation of a binary compound. And so I've got to balance now, so I've got to put a 2 for oxygen and then a 2 here, and that's it. The next type of reaction that we need to talk about is decomposition reactions. Now, as you'll notice as we look through these, decomposition reactions are extremely similar to synthesis reactions. They're just the exact opposite. So for example, AB breaks apart into A plus B. Well, if I give you, for example, K3N, that's going to break apart into its individual atoms, so K and N2. And then all you've got to do is balance. Okay? For metallic carbonate, for example, if I have calcium carbonate, metal with carbonate, it's going to break apart into calcium oxide, cross your charges, 2 plus -2, and carbon dioxide. Okay? If you have a metal bicarbonate or hydrogen carbonate, for example, sodium bicarbonate, which is baking soda, that's going to break apart into 3 different things. You've got your metal oxide, so Na2O, because I crossed my charges, H2O, and CO2. So some of this requires some memorization. Yep, a lot of it requires some practice. Now, the metal hydroxide, which, by the way, is a base, if you have sodium hydroxide, for example, it's going to break apart into a metal oxide and water. Now, this should look extremely familiar because this is just the exact opposite of the metal oxide and water synthesis reaction that we just looked at. For metal chlorate, if you have, for example, NaClO3, that's going to break apart into a metal chloride, so NaCl, and O2. And then all you got to do is balance it. So a 2 there, a 2 there, and a 3 there. The last one, if you have, for example, I'll do the exact one that we did before, H2SO3, that is going to break apart into water and your non-metal oxide, so SO2, because remember, you balance as you go. This is identical to the reaction that we looked at for synthesis, except for the fact that it's the exact opposite. So you got to identify what type of reaction you have, which of the decompositions you have, and then it's really not hard. There are a couple that you need to memorize, but the rest of them should be pretty self-explanatory with a little bit of practice. So here I've got calcium hydroxide, so I'm going to cross my charges to produce calcium hydroxide. And this is a base, so that's going to make a metal oxide and water. So I'm going to form calcium oxide, which is my metal oxide, and water. And that's it. So while for synthesis reactions and decomposition reactions, there are very specific products that could be formed, and you need a lot of practice with those. For combustion, the awesome thing is you're going to be creating the exact same thing every single reaction. So the general format for a combustion reaction, you have your hydrocarbon, okay? And so a hydrocarbon is any molecule that has hydrogen and carbon in it. It's going to react with oxygen, and it's going to form carbon dioxide and water. So it produces the same thing every single time. So ethane, you need to look up the formula for ethane. When you do, you find that it's C2H6. So that is my hydrocarbon. It's going to react with oxygen, and it's going to form carbon dioxide and water. Now the only tricky thing about combustion reaction is the balancing. So I always balance my C's, then my H's, and then my O's. So I've got 2 carbons here, 1 carbon here, so I'm going to put a 2 right there. Then I've got 6 H's here, so I'm going to put a 3 here. Now if you look for oxygens, I've got 4 oxygens here and 3 oxygens here, so that's a total of 7. So in order, because there's a 2 right here, I need to put 7 halves here, or 3.5. Now I can't leave it as a decimal like that, or a fraction like that, so I'm going to take the entire reaction and I'm going to multiply it by 2. And so what I get for my balanced reaction is C2H6 plus 7 oxygens produces 4 moles of carbon dioxide and 6 moles of water. And that's it.